Hello, AP Stats. Once again, this is part two of the Chapter 2 review video. And for starting from 27 and onwards, we have just a couple more questions to do. They're mostly open-ended and they're really different questions compared to the rest, but not that difficult, not too difficult here. All right, so let's get started. So 27, the density curve for the continuous random variable is shown below. Use this curve to find the following probabilities. So we have this curve, and if they want us to figure out the probabilities, all you got to do is just think of these as just a bunch of chunks of areas, basically. So the very first one we see is probability that x is less than 1. So you draw a line here, and anything less than 1, that is the area under this curve that you want to figure out. So what that means here is you have to figure out the area of a trapezoid. Now, if you take a look at this, they're very well spaced out, and it's going to be symmetrical, in which all of those lines or all of those trapezoids will be similar to one another. Here, here, they're all equally spaced out. So you take the 0.5, if you take a look at the height, it's kind of like dividing the height up into 4 equal sections. So 1, 2, 3, 4. So if you take the 0.5 and divide by 4, it gives you 1.25 value in each time. So what that means is the height for this should be 0.375, 0.25, and then 0.125. And obviously this will go down to 0. So now, how do you find the area of a trapezoid? Remember that it's always b1 plus b2, height of the base 1 plus base 2, times height divided by 2. So the height here is obviously 1. So 1 times 0.375 plus 0.5 over 2. So what that gives me is 0.4375. I believe that's the correct answer. Yes, so that should be for part A. Part B is pretty much the same. You do the same thing. So 0.125 plus 0.25 divided by 2. The height is still 1, so it's fine. And then, so this would give me 0.375 divided by 2. So is that 1825, I believe? Oh, I'm sorry, 1875. There we go. X is at least 3 means it's this triangle. So that's 1/2 base times height. So base here being 1, height here being 0.125. So 0.125 divided by 2 is really what you're looking at here. That will come out to be 0.625, I believe, and that should be the correct answer. Oh, I'm sorry, 0.0625. Okay, and moving on to the next one, we have 28. A gasoline tank, 12 gallons of gas, mean standard deviation, so 12, 0.2. What is the approximate probability? Holds at most 11.7. So 11.7 and holds at most that. We're asked to figure out the probability, which means we are going to go to our calculator, normal CDF, and the lower will be 0, upper will be 11.7, mean, standard deviation, and then bam. So the probability here is 0.0668, and I think that should be the correct answer here. Very simple, just that's all we really pretty much have to do. Okay, so 29 is a handful. So it seems like they have determined the breakaway forces between 3 to 5. Alpha can record from 2 companies, beta and gamma. So normally distributed with a mean of 4.5 and a standard deviation of 1. Gamma has a mean of 4 and a standard deviation of 1.5. Alpha will choose the core material that has a higher probability of breaking within the specified 3 to 5 pound limit. So you want to figure out between beta and gamma the 2 probabilities. In other words, we're using normal CDF from 3 to 5, this area within it. So going to normal CDF, we're doing lower, upper, with the mean and the standard deviation. That gives me about 0.624 of the beta. That will be the appropriate ones. Those are the pound forces that they need. Now, if I do the same thing, well, I probably have to start over. 3 to 5 with the mean of 4 and a standard deviation is 1.5. what you get is 0.495 for this. Okay, so I think we have a clear winner here. From which company should alpha order the cord material? Obviously beta, because the appropriateness of these chords between 3 to 5, well, beta gives you much more probabilities with those specified dimensions. So therefore, the beta is the clear winner here, so you should order the chords from beta. Number 30, one of the score distributions is approximately normal. I think we can both agree that it's the math. This is the normal probability plot. Remember, the only thing you have to really worry about is how linear the plot gives you. This type of curve means that this is going to be not normal. Non-normal distributions, I would say. Anytime when you see a curve in this normal probability plot, you do not want to see that. So you want a steady increase throughout the entire course of pretty much a strict line. So math concept score will be will be normally distributed because it's linearly shaped. Whereas the vocabulary score will not be because of the curves and it's not linear. All right, so number 31, what do the box plots suggest about the normality of the distribution? I really personally do not like the answer for part A, just because it's a box plot and we can never really tell the shapes. But if you have to pick between gender 1 and gender 2, gender 1 is the winner here because of all these outliers on either end. Yes, I understand that they might kind of give you still a very symmetrical shape, but because of those outliers, you might have a tendency to have skew to the left or right, depending on the distribution shape. So the normality, remember, it has to be symmetrical. It has to be bell-shaped curve. So the best chance that you have between the two, the lesser of the two evil, has to be gender 1 because of its lack of outliers. And it's just being fairly symmetrical based on how the box plot is plotted. Like I said, you can never tell the shape exactly, but the centers here with those two ends over there, still not perfectly symmetrical, but better than gender 2. Here, the normal probability distribution plot. Oh, it looks like we have a line here. Explain how it justifies assuming that the population distribution is normally distributed. You just simply have to say that the normal probability plot is linear. Therefore, we can assume normality. Or we can say that it's going to be normally distributed because of the normal probability plot being linear. Part C, according to the mini tab, we have the mean and the standard deviation. What percent would have the temperatures at 98.7 degrees or above? Okay. Again, this is a normal CDF question. We have 98.7 and we have the upper, we can just do 99999. 98.103, standard deviation is 0.700, and then paste. So we have about 19.686% or 0.9686. That should be the correct answer, yes. All right, so 2 more pages to go. The best male long jumpers for State College. We have average standard deviation. Joey has 275 and Carl has 207. So both are State College students. Find the standardized values. Which athlete had more impressive performance? Remember the two athletes that we have to compare, like Michael Jordan to Kobe Bryant and to LeBron James, or I think it was Will Chamberlain at that point. We use z-scores for this. So the z-score for, let's say, I think it was Joey. We have x minus the mean over the standard deviation. So we have Joey have 275 with the mean and the standard deviation of 14. So that should give us 12 over 14 here. Just doing the quick math, that should be 0.85714. If I did not make any mistakes, Joey. Okay, yeah, that's the male one. And Z, Carla, sister, x minus mu over standard deviation. So 207 minus 207, 201.2 over 7.7. 207 minus 201.2 divided by 7.7. That should give you about 0.75. Great. Now, the z-score being on the higher end, being positive, means that definitely Joey did better. Because of the higher z-score, meaning higher, like being further away from the norm, mean that the Joey definitely did better in the long jump. Assume that male and female jumps are normally distributed. Find the percentiles for Joey's and Carla's jumps. So the percentiles here will be, if you can just do normal CDF for both of them, I think that should also work out because we're talking about normally distributed. So for Joey, we have a mean of 263, standard deviation of 14, and we have the value at 275. So we can just go to our calculator. Normal CDF, lower 0, 275 with the mean of 263 and a standard deviation of 14. We have paste. And so that will give me about 0.804, about 80th percentile here. The same thing for Carla with the mean of 201.2, standard deviation of 7.7, the value of 207. So standard deviation, actually for the lower will be 0 still. Yeah, 207, mean of 201.2, and the standard deviation of 7.7. Oh, I just lost it. Actually, I can just delete that. There we go. So we can press paste. And there we go. So we have 77.4 percentile for Carla. And so those would be the percentiles respectively. Joey, Carla. 80.4th percentile, and then 77.4 percentile. Okay, so now let's do the empirical rule question for the pregnancies. Mean standard deviation. Pregnancies more than 300, that is 270, 123 standard deviations away. I think we had the same question here before. It's about 0.15% using the empirical rule. How short must the pregnancy be in order to fall the shortest 10%? Okay, so that's 270. And unfortunately, we cannot use this rule because 10% is not like, you know, one of those numbers that you can get by using the empirical rule. So shortest 10% means that I want to find out this x value, which this being 10% here, we use inverse norm for this. So we use inverse norm, area is 0.1, 270 with the standard deviation of 10. The value, 257 days, about that much here. I think that, yeah, the answer key says 257.184. Or about 257 days is what I would say. All right, we have our last question. Cumulative proportions. The median is very easy to get. I would say somewhere, looking at the data also, we can see that the 0.5 is clearly shown as 1 minute and 46 seconds for 2008. For the 50th percentile, I think it's somewhere maybe for 2004. 2008, 1 minute and 47.5-ish, because it's somewhere between these two values, right? So the 0.5, the 50th percentile is what we're looking at. So for 2004, it's definitely shown as 1 minute and 46 seconds. And then for 2008, it's somewhere between 147 and 148. I think for they said it was about 148, but 148 definitely just gives you like 0.625. So I guess they want you to pick something. But to be more precise, I would say between 147 and 148, just because the median has to be that. Approximate the median finishing time, but this one's definitely closer. 2.5 in comparison to actually 1 minute and 47 seconds is also about the same distance from 0.5. So I will say 1 minute and 47 and a half would be the correct answer here. But exactly between 1 minute and 47 and 1 minute 48, I think this should also be sufficient. Use the cumulative proportion graph to approximate the interquartile ranges. Remember, that's 2.5, and that's 0.75. So the interquartile range, if I look at the 2004, we're looking at the 25th percentile, which is 1 minute and 45 seconds, which is lovely. I can kind of just already see that. But 0.75 is kind of hard to tell. It might be about close to being 1 minute and 47 seconds. So for 2004, 1 minute and 47 minus 1 minute and 45, that will give me 2 seconds in total. For 2008, 25th percentile is actually at 1 minute and 46 seconds. And for 75th exactly is 1 minute and 49. So 1 minute and 49 minus 1 minute and 46, it's about 3 seconds here. That's a handful, but that's IQR and how you figure it out. You look at the 25th and the 75th percentile. Using the results from part A and B, write a sentence or two for a newspaper column comparing the two distribution of times. A sentence or two, I would say basically the spread from 2004 is from 1 minute 47 to 1 minute 48. 1 minute 43 to 1 minute 48. And for 2008, we start from 1 minute 45 because that's when the probability starts to build up. And then we end at 151. Actually, for 2004, it should be 1 minute and 49 seconds. For 2008, it should be 145 to 151. So what that means is the range for 2008 will be about 6 seconds, and the range for 2004 will also be about 6 seconds here. The only difference between the two, or did I? So 1, and then we have, yep, those two should be 1 here as well. So the range for those two times, we can say that it's going to be the same thing. Although if you take a look at the cumulative distribution curve, we have no idea where actually the value for the 2004 begins, because this is at 1.125, but before there could be some values here that we don't have any, we do not have any information to. So what you can say for 2008 is fixed in place for 6 seconds, but for 2004 the range could be higher. So for the range for 2004 could definitely be higher to a certain degree. Anything besides that, I think in the answer key they said that the variability times was a bit larger in 2008 than in 2004. In all honesty, for this, we always want to write down two distribution as SOCs for this. For the center, we have the median. For the spread, we have it. Outliers, we don't have to say it. But for the shape, what you can say about the shape here is that a vast majority of the probabilities increase quickly in the beginning for 2004, whereas it's a little bit steady pace for 2008. If a vast majority of the data happens quickly in the first half, this means that 2004 data has to be skewed to the right, because a lot of data is on the left on the beginning stage in comparison to the rest of them. Whereas for 2008, it's a little bit more balanced out. For shape, you can say 2004 has more skewed to the right, whereas 2008 has more symmetric shape. Because vast majority of the data, it kind of increases that little curve right there. It happens, a lot of the data happens in the middle of the data. And then it slowly starts to level off as you go from left to right, from the ends. So therefore, for 2008, it should be much more of a roughly symmetrical shape. I think for these types of questions, though, you don't really have to worry about going too much in detail, but make sure that you read the cumulative proportion graph and understanding how to read it. You can see how it always goes from 0 to 1, from 0% to 100%. It accumulates up, that's hence the word cumulative proportion. And the higher, the faster the curve, the more data is congested in that area. Okay. All right, so hopefully this video helps in understanding Chapter 2 materials. I had to break it down to 2 sections, but Chapter 2 is probably one of the easiest ones that you have to go through. So study well, and I'll see you guys tomorrow.